Good morning, everybody. We have got full-blown weather coverage here. As you can see, we have supercell storms that are developing upstream of Team Dominator headquarters even. And I'm very concerned about these storms that are starting to interact with a warm frontal zone. Looking at the environment out ahead of these storms, it is definitely supportive of tornado potential. And Team Dominator headquarters is located right in the path of these. We are going to be activating live storm chase mode very shortly. This storm just to the northwest of Velma has my eye right now, and we also had a tornado warning this morning at about 6 a.m. near the Will Rogers Airport. Tornado watch is coming shortly, if not already, and you can already start to see some lightning with these storms. This one just south of Comanche has my eye as well. That thing has tornado potential. A lot of lightning there. You can look at velocity. And they are starting to increase the storm relative inflow as well. So look at this storm just to the northwest of Velma. This is starting to ramp up storm relative inflow. Lightning frequency down near Addington is also starting to increase. So these definitely have some tornado potential. And this is the beginning of a major severe weather outbreak with tornado potential as well. And I'm thinking you're going to have a prefrontal confluence line that's going to be developing just to the east of the I-35 corridor, and that's going to be the source for supercell storms that are going to be lifting out of northeastern Texas into southern Oklahoma, and this is absolutely full-blown severe weather coverage happening here. We are going to be entering the Dominator 3, which is barely running right now as well because of the air compressors in the back. We also have some other issues with the Dominator 3, but hoping to get those resolved as well. So here you can see the trough shape, and this is a much more mature trough than a couple of days ago when we had a lot of that back wall power. And that was what I was saying, a trough shape that is most dangerous is one that has that back side flow right on the back side here, because that means it's a deepening trough when it's ejecting out of the Mountain West, and then that strong flow pivots around the base of the trough, deepening it through the action of shear vorticity, and then it flips around the east side of the trough in a ski jump action, and that's where you get the big time severe weather, right near the nose of that ski jump trough ejection. You have a lot of the flow here on the east side of the trough. You have a vortmax. This is basically a bowling ball vortmax in the eastern edge of the trough as well. And if you look closely, you can see that it has this neutral tilt to the trough axis. You might be initial glance looks like more of a positively tilted trough, but if you look closely at those lines of constant height, you can see right here near that bowling ball trough, eastern New Mexico, it is neutrally tilted, and that means that it's a more favorable trough for active severe weather downstream of it. It's not going to be that classic sharp dry line like we had recently where you get those supercell storms forming on a classic Southern Plains dry line. You're going to have a prefrontal confluence line out here that goes from the DFW Metroplex through eastern Oklahoma, and then you're going to have another band that's going to form ahead of that stronger mid and upper level flow. That's also going to pivot in, but you can definitely see that convection even in this model image right here. And with that mega trough, you can see a very strong low-level jet develops. This is at about 22Z, that's about 4 p.m. standard time, but you have very strong low-level wind shear in place. All those bright reds, those are 40 to 50 knot winds about a kilometer above the ground, and those are gonna yield tornado potential, and those winds are increasing with time. Looking at about midday, this is at about noon, that strong low-level jet is back near the I-35 corridor, and that includes Oklahoma City, down toward Dallas. We already have those storms initiating. A tornado watch is coming very soon. Zooming in, look at the back edge of that low-level jet axis, and any storms that form to the east of that line are going to have the potential of producing even a strong tornado or two. And the Storm Prediction Center has a large enhanced risk out for this area for that strong tornado potential. And that is the backside of the low-level jet. This is a little bit different than your traditional Southern Plains setups, and that's because of the dry line structure. It's not much of a dry line, in fact, and you can look over at surface dew points, and you don't really have that sharp dry line feature. In fact, behind that front, we'll call it, the dew points actually drop into the middle 50s, and so even though by definition this could be a dry line oriented to the north-south, you don't really have those really dried out dew points back behind it, like in the teens and 20s. with wildfire potential back behind it, but you have a ton of moisture to the east of that dry line in Pacific front. And the low cloud bases, very low cloud bases are going to be evident. And you can see that prefrontal confluence line that really sets up, even by midday, from just to the northeast of Dallas through eastern Oklahoma. And I think that that's going to be the focus for supercell development. You're going to have a couple of bands of supercells, one back here along the main front, one here along that prefrontal confluence line. And the northern extent of that tornado threat is going to be determined by this outflow reinforced warm front that lifts up near the Kansas-Oklahoma border. It's probably going to be curtailed a little bit by the Ozarks, by some of that complex terrain up there. But any storms that are able to ride that warm frontal zone, those will also have a tornado threat as well. And a lot of times along those warm frontal zones, you'll get a little bit of enhanced low-level wind shear, some more backed winds. So really locations like Oklahoma City, Dallas, on the I-35 corridor, up toward Tulsa, maybe even Springfield. You've got an arm of that strong tornado threat that extends all the way up into the Springfield area along the I-44 corridor. In the latest outlook, that's anticipating that warm front to lift up into southwestern Missouri. A lot of those forecast models are showing that. Looks like there might even be a bit more of a dry line punch down to the west of the DFW Metroplex. But really, what we are most interested in is that prefrontal confluence line. And let me show you, the HRRR also has that zone down here just piping into southeastern Oklahoma by midday. You got your front back to the west, tornado potential even into central Oklahoma as well. So let me show you now what the composite reflectivity looks like here. This is at 18Z by about noon Central Time. There you can see some of those storms starting to develop along that front. And you can already start to see the formation of these renegades down to the northeast of Dallas. That's where you have the greater instability. I think that's probably going to be, we'll call it the main event, but you're going to have round after round of supercell storms. Even the main front convex near the I-35 corridor, these are going to have the potential of producing tornadoes. These renegades coming out from northeast of Dallas into southeastern Oklahoma, those definitely have my eye out there. So those are going to be developing in a prefrontal confluence band. They are moving into an environment of extreme wind shear too. Watch what happens when we go to about 3 p.m. Central Time. It looks like these renegades down just to the east of the DFW area become even more vigorous, as does this line. You're also going to have these storms up near the warm frontal zone in northeastern Oklahoma by about 3 p.m. Those are going to cause some problems too. And watch the low-level jet intensify as we go to 22Z, closer to the magic hour. Look at that low-level jet, 50 to 60 knot southerly 1 kilometer winds, lifting up from northeastern Texas through eastern Oklahoma into western Arkansas. That's going to allow these mesocyclones to tighten up at the low levels and even produce a strong tornado or two. You're just going to have a conveyor belt of supercell storms coming from east of the Dallas area, and those are just going to move over the same zone into southeastern Oklahoma near that Red River region. But the threat of tornadoes goes all the way up to the northern edge of this low-level jet, up into northeastern Oklahoma, southeastern Kansas. It's a little bit wavy. It's outflow and topography reinforced up there. Sometimes you can have some higher terrain near the Ozark Mountain Plateau, and that'll kind of slow the advance of a warm front, but that's going to be the northward extent of that tornado potential. And the risk, the 2% tornado risk, goes almost up to Peoria, Illinois. But you can see this little belt of a stronger low-level jet that comes out of northeastern Texas from the Paris area up to Idabel, Broken Bow, Fort Smith. That's going to be an area with very strong low-level wind shear. So any supercell storms that move into that environment, they are going to have the potential of producing some strong tornadoes. There you can see that little pop of a low-level jet. It's a little bit stronger there, 60 to 70 knots. And this is just ahead of that prefrontal confluence line. Northeastern Texas into southeastern Oklahoma into western Arkansas, nosing up into the Ozark Mountain region. That's where I'm most concerned for the tornado threat. And let's look at a forecast sounding at about 4 p.m. down near the Idabel area, and you can definitely see a lot more favorable of a hodograph for tornado potential there with that strong curvature. And you can also see your mid-level dry slot right here, elevated mix layer. Mid-levels of the atmosphere coming in, giving you a little more cape, a little more instability, and you've got a 74 over 70, nearly 300 0 to 1 kilometer storm relative helicity, all because of that 50 to 60 knot due southerly low-level jet right there, creating a big hump in the hodograph And you're going to have a southwest to northeast storm motion at about 35 knots of those renegades as well. But that's the environment that I am most concerned about for dangerous tornadoes, and it's over this complex terrain out over eastern Oklahoma into western Arkansas. Some of the most difficult storm chasing terrain on the planet out there in northwest Arkansas. Probably portions of like eastern India into Bangladesh are probably a little more difficult too. But there's your wavy warm front, reinforced by outflow and a little bit of topography as well. And watch what happens as we go towards 0Z. We call this a magic hour because the low-level jet accelerates. And look at that into southeastern Oklahoma, folks. That's at 6 p.m. Central Standard Time. Northeastern Texas into southeastern Oklahoma, nosing up into the Fort Smith area. That's like a 70-knot low-level jet. Major winds right there. And any supercell storms that evolve into this environment, and notice how that low-level jet lifts up north of the I-44 corridor by about 6 to 7 p.m. That's going to bring that tornado potential up and eventually up even into like central Illinois. That tornado potential could be happening. But watch, look at the convective evolution here in southeastern Oklahoma. Those are all renegades, renegade supercell storms. This one's going to be nasty up there near Fort Smith. These coming out of northeastern Texas into southeastern Oklahoma. Warm front riders up here into portions of Missouri. Definitely dominate this like button, folks, if you like in-depth breakdowns. I know a lot of this stuff doesn't make sense. Sometimes you can reject things that don't make sense, but I am here to walk you through the science. And this warm frontal zone, even in the St. Louis area by evening, could become a focus for tornado potential as well up near St. Louis. Very strong wind shear is going to be evolving. Watch out for these Ozark Mountain Plateau storms out there. A lot of times the higher terrain out there can make tornado genesis happen. Remember earlier this spring when you had those like 2-mile wide tornadoes up there? So watch out overnight tonight, 7, 8, 9, 10 p.m. That includes like Walmart headquarters up there, Fayetteville area. Gotta watch out for those tornadic supercells. Let me, there's the epic pen to circle that cluster a little more effectively there. Riding that boundary, that state boundary between Missouri and Arkansas near Branson. I've been on a bunch of tornadoes across that area down there. Northwest Arkansas, southwestern Missouri. Let's check back and see how some of those storms are doing. And there you can see they're starting to intensify just to the west of Team Dominator headquarters. But it looks like they're struggling a little bit with the thermodynamics so far, even though the wind shear is very strong. Sometimes when the wind shear is so strong, it can lead to a low-level mesocyclone that's capable of drilling down through that stable layer and becoming a tornado. This is definitely a mesocyclone here to the north of Velma, Oklahoma. You can see kind of enhanced storm relative inflow into that. Has that sickle shape to it. Probably a little miniature RFD down there even. And this means that it's pulling in some inflow. This storm's a little bit more intense to the west-southwest of Velma. And the key is to use echo tops to see which storms are the most vigorous. And you can see this one's a little bit larger, a little bit higher up in the atmosphere there. Just to the northwest of Loco, where we got that tornado in 2023 with Jordan H. Hall behind the wheel. And then you got some of these tops up to the east of Bray, Loco, Velma. But this right here is a sign of warm advection on the nose of the low-level jet. Those showers there, that's all isentropic lift, as we call it. That's from the southerly low-level jet just pumping northward, and you get little showers that'll form along the leading edge of that. Pretty crazy. A couple nights ago, Saturday night, those tornadoes in Oklahoma City, including the southeastern suburb of Oklahoma City near Valley Brook. These were definitely very apparent on radar, and we can go back and take a look at some of these as well. Like November 2nd, I think, right? let's see, that's Sunday, Saturday. You can see some of these storms. Team Dominator headquarters was just piped by this event. And numerous tornado warnings moved through that area. Looks like, I wonder if that was November 1st. Oh, November 3rd. We're in the AM now. So there you can see these supercell storms. This was the night of the 2nd, Saturday night. And this is at 1:30 in the morning. Ongoing tornado there, north of the radar site. These are a dual EF3 tornadoes too. And you also had these crossing the Red River. This one crossed the Red River, producing dual strong tornadoes. It was unwarned even as it crossed the Red River. I heard that the National Weather Service is quite understaffed these days, and that was the reason why. So you definitely have to feel for those people. You know, but this was a dangerous storm out here. They were tornado warned by the time they got up to Team Dominator headquarters. But Doug from AccuWeather here probably had to take shelter like 5 or 6 times. He was in extreme danger here at Team Dominator headquarters. He said that the power went out like 5 or 6 times. The Dominator 3 air compressors died. Thank you to Brandon Kopic and Corey Gherkin and Local Man Weather for fixing that. Thank goodness for you guys. Going a little bit earlier, I think this was the storm. That was just classic nocturnal outbreak here. And these were moving into an environment with like 5 to 600 0 to 1 kilometer storm relative helicity. And here you can see that thing getting going out near Dibble. And it's already got a strong mesocyclone out there. I believe that this one eventually became that EF3 tornado producer, and you can see that it's got that classic supercell structure. Even have a little bit of a lubrication of the low-level environment down there. Sometimes that can even enhance the low-level wind shear. But this is a classic sickle-shaped supercell, probably already going through the motions, producing a tornado down near Dibble Saturday night. We'll go forward a little bit toward 1 a.m. And I know there was also a time change out there. And yeah, that one went up, produced that tornado near Valley Brook. Let's get that closer to 110. EF3 damage out there. Look at that thing. So you can obviously see it has that very smooth laminar appearance to the forward flank gust front, pulling in a ton of inflow. Here's your compact rear flank downdraft on the south side. So you are in danger in the path of a storm like this. And again, this was Saturday night. We're doing a recap now for Saturday night, folks. Even though we've got super showers forming just upstream. But this is a major problem here. Needs to obviously be warned. Anytime you get that smooth curvature there, and right near the apex there, the rear flank downdraft, and where that's going to produce a tornado, we'll go over to velocity. And this produced a dangerous EF3 tornado. This is your convergent couplet, basically showing strong convergence right along the radar radial. So this shows a convergent zone, kind of an elongated zone of convergence or even spin. And as it gets a little bit, changes its orientation. But this is a dangerous storm right there. Anytime you get these elongated zones of potential vorticity and convergence, they're about to go berserk. We'll step forward to 120. And oh my goodness, EF3 tornado. So see how fast it goes from that broad convergent couplet to a damaging tornado approaching Highway 240 there. There's Valley Brook, southeastern suburb there of Oklahoma City. This was Saturday night, and that did a lot of damage. Preliminarily rated an EF3 tornado. But you'd have to be able to anticipate the evolution of a tornado like that. And you can see the debris, TDS, tornado debris signature, that close to the radar, showing that low-level debris. Multiple radars showing that. Radar interpretation is not difficult, that's for sure. You just have to have the staff there to do it, of course. And you look a lot closer. Here you can see a compact RFD gust front, strong westerlies back behind it. And that's where your tornado would be located. right on the apex, right on the northern part of that RFD gust front there, folks. A velocity couplet, storm or relative velocity couplet. But that was Saturday night, and we are going to have more nocturnal tornado potential tonight, but it's going to be more over southeastern Oklahoma. And look at this one coming up. This one just racked Team Dominator headquarters. Tornado producer down near Bray. This was Saturday night, and Team Dominator headquarters had like 5 or 6 tornado warned supercells move right over. Most of those did have tornado warnings. There's another tornado producer down here, just east of Wichita Falls. Prefrontal confluence. And I think you also had an arrival of an elevated mix layer over top of that, creating a little bit of a dry over moist profile. But these were a string of supercells Saturday night coming southwest to northeast, just racking that area. So let's go back to the present live. Obviously not as vigorous of convection, but watch out for this one, folks. It looks like it's going through the motions here. And we're right in the path of this storm. But it is starting to ramp up its storm relative inflow here, just to the west of Elmore City. That area there in the lighter green and blue, that is ramping up storm relative velocity. You also have it down southwest of Velma. So that's a storm that has increasing tornado potential, and it's coming right at us. It's coming right at Team Dominator headquarters here. Right where I'm broadcasting. Watch that thing intensify and get that shape. It's getting that classic sickle shape there. Southwest of Maysville, just south of Lindsay. Watch out. These things have tornado potential, folks. We're going to have to activate storm chase mode now. So thank you, everybody, for tuning into this live update. Be sure to share this stream, breaking down our forecast target area. It's really going to be later on this evening, northeast Texas coming into southeastern Oklahoma, but the tornado threat has already begun. Tornado watch coming soon if it's not already out for that blue area. That's your mesoscale discussion. Thank you, everybody, for tuning in to this live emergency update. Thank you, everybody. I am going to be activating storm chase mode immediately here because we got to chase this thing, and it's very important for me to be on the ground looking at these things as they're happening. We'll be activating our live stream as soon as Brian wakes up. Thank you, everybody, for tuning into this live update.